All right, let's get right into it. Neuralink just dropped a huge update, and we need to talk about it. Because what we're about to explore isn't just some new piece of tech. This is something that could fundamentally rewrite the rulebook on what it even means to be human. And this quote from Elon Musk, man, it just hits the nail on the head. You can replace almost any part of your body, but not your brain. Why? Because everything you are, your memories, your personality, your consciousness, it's all happening right in there. It's not just a part of you, it is you. So yeah, let's start with that idea. The brain is you. Think about it. This 3-pound universe inside our skulls is how we experience reality. It's this incredible biological computer that somehow figured out how to ponder the stars. But, and this is a big but, for all its amazing power, it has one major bottleneck. It's like this. You have this beautiful, high-definition movie playing in your head, a complex idea, a feeling, an image, and to share it with someone else, you have to try and describe it frame by frame using the slow, clunky tool of language. You lose so much in the translation. We have a serious bandwidth problem. But look, before Neuralink can solve that grand, futuristic problem, they're tackling a much more immediate and devastating kind of disconnect. The kind that happens when an injury or a disease cuts the link between the brain and the body.
And this is where we meet the real heroes of this story. These are the pioneers, some of the very first people in the clinical trials. You've got Nolan, who has a spinal cord injury, Brad and Mike, both living with ALS, and their goals aren't about becoming superheroes. They're about reclaiming the things we take for granted, doing things on their own, working, communicating, just getting a piece of their life back.
So how is this even possible? Well, it's through something called a brain-computer interface, or BCI. The simplest way to think about it is like this. It's a direct bridge from your thoughts to a machine. It literally reads your brain's intention to do something, like move a cursor, and makes it happen on a screen. No hands required. Okay, so we have this bridge. What can you actually do with it? Well, this is where things get wild. Neuralink's first product is called telepathy, and honestly, the name fits. What these pioneers are already achieving it's just mind-blowing. Get this number, 7 BPS. That stands for bits per second, and it's a measure of how fast and accurately you can control a cursor using only your mind. Now, for perspective, on his very first day using the device, a Neuralink participant didn't just meet the existing BCI world record, he absolutely shattered it. First day. And that kind of control unlocks so much. We're not just talking about checking email, we're talking about people playing Mario Kart, even Call of Duty, just by thinking. They're doing professional 3D design work. They're writing code. They're drawing with robotic arms. They're working full-time jobs and taking online classes. They're living their lives again. But you know, for all the amazing tasks they can do, maybe the most profound impact is in this simple quote from Brad. Because of his ALS, his old eye-tracking device didn't work outdoors. For 6 years, he was essentially trapped in his house. With Neuralink, he said, "I go outside now." Just think about that. After 6 years, that simple freedom, that's what this is really all about. So all of this sounds like something straight out of science fiction, right? Pure magic. But it's not. It's the result of some seriously next-level engineering. So let's pop the hood and see how the heck this thing actually works. It really boils down to 4 key steps. First, a special robot, one that's way more precise than any human surgeon, carefully places thousands of these hair-like threads into the brain. Second, the implant starts listening. It records the electrical signals from the motor cortex. That's the part of your brain that's shouting, "Hey, I want to move my hand." Third, and this is the secret sauce, a machine learning model decodes that complex brain chatter in real time. And finally, step 4, that decoded thought becomes a command. Your intent to move a cursor becomes the cursor actually moving. It's that direct. And remember that whole bandwidth problem we talked about at the start? Well, this very same technology points the way to solving that too. I love the analogy the team uses. They say right now speech and text are like an old 56K dial-up modem. Screeches! Their goal is to upgrade humanity to a broadband connection, a way to share entire concepts and ideas instantly and without loss. So, restoring motor control is incredible, a total game changer. But you have to understand, that is just step 1. It's just the beginning. The roadmap for what they want to do next? Well, it's insanely ambitious. So check this out. In just the next quarter, they're aiming to decode silent speech, reading words right out of your brain. By 2026, the goal is blind sight, restoring a form of vision for the blind by feeding signals directly to the visual cortex. A year after that, in 2027, they plan to use multiple implants at once. And then, by 2028, they begin the really huge one, starting to integrate our brains directly with AI. And if you look even further down the road, the possibilities get even more wild. I mean, imagine using implants to bridge a severed spinal cord and let someone walk again. Or the ability to mentally log in to a humanoid robot like Optimus and experience the world through its sensors. This tech could even be used to address conditions like severe depression. It's a whole new paradigm.
So, when you put all of this together, from helping someone move a cursor to playing video games to one day merging with AI, it all comes down to one massive question. What does this mean for the future of the human experience itself? When you strip it all away, what's happening here is really elegant. We are connecting our brain, a biological neural network, to a machine running a silicon neural network. The AI that we built by taking inspiration from our own brains is now being used to come full circle and actually extend the power of our brains.
And that brings us to the final civilization-level question that really drives this whole project. As artificial intelligence gets exponentially more powerful, and it's happening fast, how do we ensure that humanity doesn't get left in the dust? A high-bandwidth brain interface might not just be a medical miracle, it might be a necessary tool for humanity to keep pace. It's a heavy thought, but it's one we're all going to have to think about. So, what do you think?